What's up, everybody? This is Danny Mathematics here with another example to explore, guys. And today, guys, I want to go over example 3 and example 4 of how to find the volume of 3D shapes, which in this case, guys, we're still dealing with prisms, right? 3D shapes that have two bases. How are we going to find the volume of a 3D prism, right? And remember, guys, finding the volume is just the max amount of area, not even area, the max amount of space within a 3D shape that can be filled, okay? So for example, guys, if you was to fill up a cup of water, right, all the way up to the top, that's volume, because we're filling up the inside all the way up to the maximum level within the 3D shape, okay? So that's one simple example, all right? So let's go over example 3 and example 4. We're gonna do that real quick. And remember, guys, the volume formula for all prisms is big B, which represents the area of the base, times the height of the whole prism, okay? Right? And remember, guys, depending on the shape of the base, big B is going to turn into any one of these area formulas. Either a rectangle, for rectangles, it's going to turn into this formula. If the bases are triangles, it's going to turn into this formula. If the bases are shaped as circles, they're going to change into that formula. And once again, we know that H is the height of the whole prism, or the distance between both bases, however you want to look at it, all right? So let's go and let's do the first example. It says, what is the volume? Here, guys, I have a rectangular prism because I have two bases, top and bottom. I have them shaded in blue, right? And both bases are represented as rectangles, right? Or they both are in shape of rectangles. So I have a rectangular prism, all right? So let's go ahead and write out the formula. So the volume formula for all prisms is V equals big B, which is the area of the base. So we have to find the area of the base to get the value of big B, times the height of the whole prism, all right? Or the distance between both bases, right? The first thing, guys, that I can automatically see is the height of the prism, right? Or the distance between the top base and the bottom base, right? So 15 inches in this case is H, which is the height, right? H. So I can already put 15 as H if you would like to, all right? You can already put 15 as H. Okay, 15 as H. And then now, guys, we're gonna find out the value of B, and then we're gonna multiply that by the height of 15, all right? Now B, guys, what formula does B turn into, right? What area formula does B turn into? Remember, guys, it depends on the shape of the bases. So in this particular case, guys, the two bases, which are congruent or equal in size, are shaped as rectangles. So big B is going to turn into the area form of a rectangle, which is base times height, right? So let's go ahead and do that. I'm going to do this right here. So big B, it is a rectangle. So I just drew a little rectangle underneath representing that. And it's going to turn into the formula of base, which is the small b, which is the horizontal side of this of the rectangular square, times h, which is the elongated side or the height of the rectangular base or square, whatever, right? So as you can see, guys, the horizontal side, which is small b, is 20 inches. And then the height of the rectangular base or bases is 25 inches. So to get the area of just the rectangular bases, I have to do 20 times 25 to get the value of big B, okay? And 20 times 25 is 500. 20 times 25 is 500, okay? So the area of the base is 500, okay? But I have to multiply this by this 15 inches of height, all right? I have to multiply that by the 15 inches of height to get the volume, all right? So that's what I'm gonna do. So once again, big B is 500. So all this shaded in inside has an area of 500 square inches, right? But remember, guys, volume is dealing with 3D shapes, how much I can put inside of something, right? So these 15 inches height creates all of this space of volume, right? All this space that can be represented as volume. All right, so what I'm gonna do is I'm gonna multiply the area of the rectangular base, which is 500, by the height of the whole prism, which is 15, which will give me the volume. All right. So 500 times 15. Let me go ahead and give you a calculator. 500 times 15. Give me 1 second. 500, excuse me, times 15 is 7,500. 7,500, guys. So the volume of this rectangular base, of this rectangular prism rather, right, is 7,500 cubic inches. That's inches to the third power because we're dealing with a 3D shape, right? So cubic inches, that is the volume of this particular rectangular prism. This is the volume right here. That's the volume. All right, so that's how much space within the rectangular prism that can be filled up. So we was filling it up with water, or we was packing a whole bunch of Skittles or M&Ms inside all the way up to the top. That's how much volume of space within that can be filled, okay? So now let's go ahead and go to example 4. Example 4, I have something different. I see that I have a prism because I have 2 bases, but the shape of the bases are triangles. So this is a triangular prism, okay? This is a triangular prism, which follows the same volume formula, okay? So once again, volume, which is V. And remember, this is the volume formula for prisms. For pyramids, it's gonna be different, all right? So volume equals big B, which is the area of the base, times H is the height of the whole prism, or in other words, the distance between both bases. As I can see, guys, if this was the bottom and this was the top, then right here would be the height. This would be the height right here, which is H. So I already know, guys, that the height is 58 feet. So I'm gonna go ahead and set that as H, 58 feet, okay? Now I need to find what is the value or what is the area of the triangular bases, which is big B, right? That's what I need to find out. All right, so because, guys, the bases are shaped as triangles, right? Big B is gonna turn into the triangular formula, the area formula for a triangle. Okay, so I'm just gonna draw a little triangle underneath, meaning that that is the area formula that it's gonna turn into, right? Which is base times height divided by 2. So small b times h divided by 2. Okay, that's all we're doing, guys. That is all we're doing. We're gonna get the value of big B. Let me get my chair real quick. All right, so small b, guys, which is the base, which is the horizontal side of the triangle, right? Which is 30. So 30 feet is small b, right? And h is just the height of the triangular base, which is 35. So h would be 35. So let's go ahead and put that, guys. All right, so once again, b is 30, which is the horizontal side, times the height of 35. All right, divided by 2. And that's going to give us the area of the triangular base, of triangular bases, rather, right? Equal. All right, so now I'm going to do 30 times 35, right? That is 1,500 divided by 2, which is 525. So the area of the triangular bases are 525 square feet. All right, 525, right? Right, so which is this, 525, right? So if we only had the base, it would be 525 square feet. But remember, guys, we're dealing with volume, so I gotta multiply that by the height, right? Which is showing all of this filled in space, or this space that can be filled in inside, right? So that's when I'm gonna move this value and plug it inside of the volume formula. So once again, we have the value of big B, which is 525. And I'm going to multiply that by the height of the whole prism, which is 58. So 525 times 58 feet is 30,450. So that is the volume, guys. That is the area of the capacity inside that can be filled up, okay? So the volume is 30,450, since we're dealing with 3D, cubic feet. Feet to the third power. Feet to the third power. Cubic feet, okay? 30,450 cubic feet. This is our final answer, and this is the volume of this triangular prism, all right? So once again, guys, this is how we find out the volume of prisms, right? Whether it's a triangular prism, a rectangular prism, a cylinder, or whatever, guys, all right? So thank you so much, guys, for tuning in. Have a great day, and I'll talk to you next time.